My name is Tomasz KLEPACKI, and I'm excited to share with you the results from over 2 years of work from the Signal project. Today, I will present a case study on how we implemented a continuous delivery process. And as the QA DevOps lead of for the Signal project, I will demonstrate how we achieved the highest possible level of automation in the software development. This was mainly achieved by providing the test automation at the various level. Okay, a quick question to the audience. Have you ever introduced the continuous delivery in your projects successfully? Oh, I didn't expect so much amount of the raised hands, but it's good to hear that. Okay, before I move on to the full presentation on the path to automation, I would like to say a few words about the project itself and the company where I had the opportunity to oversee quality for over 5 years already. So Signal Ocean is a part of the Signal Group, the Greek conglomerate that includes companies related to the maritime transport. The group has several offices, included headquarters in Singapore, London, and with its main headquarters in Athens. The main and the most important product being developed by the teams in Signal Ocean is the Signal Ocean platform. The Signal Ocean platform is the technology web platform that offers services for managing and monitoring maritime transport, as well as analyzing the data related to the freight market. So it was designed to help maritime transport companies, ship owners, ship brokers to make more informed decisions. So let's now talk briefly about the architecture of the platform itself and the technology that we use to build it, as these are crucial to understanding the testing strategies we decided to use. So the platform is built on the microservice architecture, with each microservice is autonomous, has its own API, has its own database, and is developed and scaled autonomously. This is very important. And we also use a backend for front-end approach, which optimizes the communication between front-end and backend, particularly with this large kind of the project like the Signal platform. And this enables better isolation of functionalities and also better code management. And of course, we need to remember the front-end side. The front-end is built using React.js, and entire infrastructure has been hosted by the Azure Cloud. OK, let's go back 4 years to 2020, when I joined Signal as a senior test automation engineer. And what did I find? We used 3 environments, unstable, QA, and production environment. So what was the unstable environment? It was the environment when we got almost every new feature and the bug fix. It was many times not tested fully. Many times the environment wasn't working fully. It was kind of the, like it's a downstable environment. We also had the QA. And this environment received pre-tested and selected changes or the features for the release into the production. And of course, the production, this was our final production environment. So we made release packages every week, which with all the changes or the bug fixes planned for the production. And what kind of types of tests we used? We used, of course, the unit test, which checked the backward or front-end logic. We also used the DOM snapshot test. This type of test checks the HTML structure of the actual structure and the expected structure. And additionally, we executed the UI test by using the TestCafe UI automation framework. So we ran visual regression test, a very important part of our test suite. I will tell a little more details about it later. And front-end, back-end tests without mocks, because the visual regression tests were mocked, all the responses to provide the stability of the test, but we also ran the front-end, back-end tests. And yeah, like I said, the preselected fixes or preselected features were deployed to QA, then were tested, and then deployed to production. At first glance, the process seems to be correct, but over time, I noticed some significant flaws. First one is that developers couldn't test their changes in a fully integrated system. Like I said before, all of the changes were deployed to unstable. Many times this environment was blocked because one of the untested feature hanged this environment, let's say. So also local tests on developers' machines also lacked full integration. So this was a problem for us. Also, the execution times of the UI tests was so long, and the tests were so unstable that they were not included in the CI pipeline. So we wanted to avoid them to become the bottleneck, right, of the CI process. That's why we didn't include them in this pipeline. Since tests were run infrequently and in an environment with many simultaneous changes, it was often difficult to link the specific test failures to a particular code changes. This was also really hard for us. And UI test in general, the test coverage was very limited. Like, we didn't have any kind of the API integration test at that moment. We also struggled with the observability level because sometimes the backend service, not the frontend for backend layer, but the backend service, which is at the bottom, was failing, and it caused the issue which were visible at the top layer. And it was really hard for us to find out where there is the root cause of the failure. Also, according to the UI testing tool, TestCafe also did not fully meet our expectations, which I will discuss it in more detail soon. Yes, I already told about this problem with the observability here, especially related to the backend services. And yes, releases. Releases were infrequent. They occurred only once a week. They included large amount of tasks, which is not very good practice. And we also sometimes need to retest all the test builds, test suite that we have, because we wanted to add at the last moment, I don't know, the one additional feature, right? And the last one, hot fixes, where many times bypass the unstable branch. They cause the environment inconsistencies, and it making necessary to back merge from QA branch to unstable branch. So these are all the things that didn't work from my side. And yeah, changes needed to be made. Where did we start? When I began working on the SignalOcean project, my first task was to review the UI test and improve the test case-based framework. For those who are not familiar with the TestCafe, TestCafe is a UI test framework for testing the web applications developed by DevExpress, similar to Cypress, Selenium, Playwright, this kind of tools, and it allows for running the functional tests and the acceptance tests at the highest level, at the graphical user interface level. Unfortunately, we faced several problems with TestCafe during our testing. Debugging was very tough because their error message were hard to understand, and running the test was not easy because we run many times the test with command line, and running the specific test means to run the very long commands. TestCafe didn't have a built-in way to mock the request. This was very important for us because we used it in visual regression test. And instead of it, we had to create our own mocking, custom mocking mechanism, which didn't work very well at that moment also. And last but not least, the parallel mechanism that TestCafe provides was not perfect. It didn't include at that time the load balancer, which distributes the tests equally. We had to split them manually, like into the smaller chunks, which cost us the maintenance, additional maintenance. And because of this issue, we started looking for a different UI testing tool. As Cypress was gaining popularity, we decided to evaluate it, of course, for testing our application in SignalOcean. And in 2021, it was the second most popular front-end testing tool, according to the State of Testing report, and one of the top 3 JavaScript testing tools, according to the State of JS. We didn't consider very important thing. We didn't consider Playwright, as it was still a very new and immature project at that moment. Playwright is popular right now, but in 2021, it wasn't, right? So when choosing a new tool, we prioritized its ability to parallelize tests, to speed up UI test execution, to avoid the time bottlenecks, right? So in general, many development teams struggle to integrate the kind of test because many times it's take a very long time for the test execution. So many times teams decide to run the test in the morning or at night, which is not very good practice because we are not linking specific commits with the specific test results, right? So this is why we focused on test parallelization when we evaluated a new tool. And we decided to use Cypress. And with the right tool in place, we began to migrate all our existing tests from TestCafe to Cypress, while also gradually increasing the test coverage, right? So to ensure this test coverage, we decided to use the traceability matrix, which offers us the mapping between requirements and the test that we want to be automated in the future, for example, right? So by this, we had the control on which tests have been already automated and which not. So over time, we reached 220 front-end, back-end UI tests and 620 mock tests for visual and regression testing. So over time, we reached a point where we were running many tests. So let's take a look at the statistic. For 1 month, we ran 245 different types of UI test builds, right? A large number. However, as you know also, the number of tests and coverage aren't everything. The execution speed is also crucial. So the execution speed, as you can see, for the 620 tests is 14 minutes, which I think that this result is quite impressive. So how we achieved this impressive test execution times? By implementing two-level parallelization. We started by using 4 virtual machines that were managed by our CI server, TeamCity. That was the first level of parallelization. And the second level of parallelization, we ran multiple Cypress instances. Gleb called that it's not a good practice, but we did that in the Docker. In his previous speech. And it was really safe to run this. And we had powerful machines to run like 4 threads on one machine. So in total, by combining these 2 levels of parallelization, we were able to run tests on 16 threads simultaneously, right? So another thing, even though the individual test runs were relatively short, we encountered a new issue. Very long QA times for test execution. So the obvious solution was to run multiple test builds simultaneously, but it was very hard to achieve because we had too few virtual machines available, and we needed to assign TC agents to virtual machines, which caused the additional costs. So eventually, we found a solution to overcome this limitation by using the Azure Batch. So what is Azure Batch? Azure Batch is a service that creates and manages a pool of virtual machines, installs the application we need, and schedules tasks to run the tasks that we want, for example, test on these individual machines. So we can manage the pool. We can manage this pool by using, for example, the Azure Batch program, the API, or the Azure portal itself. So there are no extra fees for using Azure Batch. We only pay for the resources we use for such a, for example, like a virtual machines, storage, or networking. OK, now let's take a closer look at the steps performed by the Azure Batch process. The first step is running the Azure Batch process by a program. It was actually run in .NET stack. Then it creates the pool of VMs. After it, the job is assigned to pool, and then multiple tasks are assigned to job. On every VM, the tests are executed, and then after the tests are executed, we are deleting the job and the pool, and the results are gathered in TeamCity. So as I mentioned, using this new Azure Batch-based test infrastructure, we were able to minimize the number agent use. So in comparison, we didn't use 4 agents. We used only 1 agent, only for running the Azure Batch program. Now let's compare both solutions in terms of duration. For example, in the classic solution, running UI test mock took about 40 minutes. And in contrast, when we ran this, the same test, the same amount of tests with the Azure Batch, it took more than 50 minutes. And why? Because Azure Batch needs some time for example, for pull node creation, for installation of all VMS dependencies. But as you can see, the test run itself took only 8 minutes and 40 seconds. But what we really achieved, despite this, we achieved the parallelization of test build, and it was our primary goal. So I would now like to take a moment to highlight the importance of visual regression testing of all platform. So as we increased our coverage of functionality with visual regression tests, we found out that these tests are very important for us because they find very large number of defects. So we use the specific library for that, the Cypress library, which is called Cypress Image Snapshot. And what is the visual regression testing? It just compares the actual and expected images. It was very important because in our platform we used a lot of maps, and they were not handled by the DOM structure. So it was really hard to catch the specific elements, so that's why we decided to use the visual regression. So here on the slide, you can see the example of image generated after detecting the differences between the expected safe snapshots and the capture image. So this was really easy for debugging, right? This kind of the visualization. So after some time, we decided to, maybe not decided, we noticed a significant gap in terms of test coverage. Due to that, and we found out that we don't have any API integration test. So we decided to create a simple sanity test for the API integration by using Postman service, which will only check like 200 or the status codes actually, if there are 200, for example, or 201. So what did we use actually? We used the Swagger JSON schemas for generating the collection, and then we used the Swagger example to provide the parameters for the specific endpoints. And by this, we're able to run this test. It was not very expensive regarding the maintenance, because all the tests were defined actually in the Swagger documentations, right? In the Swagger examples. So here, for example, you can see the value that was added to the path. And this value is an example from the Swagger documentation. Yes, service monitoring and observability. This was one of our pain points. We decided to add different kinds of open telemetry tools, like application insights, like Jagger, like Rapid7. We also decided to add DOM health checks, and we also started running some monitoring tests, UI tests in the production. It increased our observability about the state of all the services and also the production environment itself. This is the thing that I'm really proud of, this improvement. We created a mechanism for dynamically creating dedicated platform environments for each pull request. So this means that each developer has its own environment for each pull request. So he could change anything he wants. He was able to change the permission without any issue for the others. And here we have an admin panel, where we can, for example, see which environments were created, to which Jira item is assigned. We can manually delete them. We can see the state of the app service or the database. So yeah, this is how we look. And now let's take a look at the holistically at the continuous delivery process, how it looks actually. So it all starts with creating a PR in Azure DevOps. the changes in this PR are supposed to go to the main branch. This is a very important thing related to the continuous delivery. So we are avoiding targeting like the release branch or the dev branch. And after PR is created, then the API integration tests are run, we run some unit tests, and then the dynamic environment is deployed. Like I said, this dynamic environment is set up for specific PR. And on this PR, we also run the UI test, the front-end, back-end test, and the visual regression tests, which are mocked. And then, when all tests passed, it's completed, and then, of course, there is one thing, manual thing that needs to be done. Product owner needs to accept the PR. So this is the only manual step that actually needs to be introduced here. So after it, we have a slot swap pipeline mechanism. We are deploying the changes to a staging and unstable. And we are running some last tests to make sure that everything works fine. And after it, we're running the slot swap. And the last thing, I know that I reached the time. So yeah, here we can see how the example, how the PR looks like and what are the characteristics. So for example, on the right side, we can see all the status checks that are green. And then they involve all the tests that we run during this pipeline, like the UI tests, front-end, back-end tests, and the others. OK, that's it. Thank you very much. Looking for your questions.
If you need to choose now, should you choose Playwright?
I was expecting this question, to be honest. OK, so what you don't know is that, actually you know that, because I already told about it, because we provided this continuous delivery process like 2 years ago or 3 years ago. But like half a year ago, we migrated our test to from the Cypress to Playwright. And what is the reason behind it? The reason is that we used the sorry Cypress as the tool for the parallelization. And it was blocked by the Cypress in version 13. And we've also seen other advantages of the Playwright. So that's why we decided migration. One of the things that caused our migration also is that most of our stacks is Microsoft-based. So as you know, Playwright is also Microsoft-based. So we decided to migrate to Playwright, which took like 3 or 4 months. We had in total like 900 tests that needs to be migrated. Yeah. So yeah, we are already using Playwright.
OK. What language do you prefer for Cypress? What weak points do you experience in relation to Cypress?
We are using the actually the TypeScript for, we used TypeScript for the Cypress test implementation. I think I'm the person that think that we should use the language that is similar to the layer that we are testing. So the front-end layer is usually created in JS or TS. So that's why I think that the test also should be created in this language. And also why? Because if we need more hands to work on the UI test, we can also include the front-end developers, which are familiar with this kind of language, because they normally make the implementation of the front-end. And the same with the back-end. If you have, I don't know, the .NET or the Java, for me it makes sense to create the back-end test for this specific language.
Next question. Did you encounter flaky tests? How did you deal with flakiness?
Yeah, it's really common with the flakiness. So what problem we had related to the parallelization in general, one good advice is to, for example, if you have users for making actions in your app, it's great to create dynamically a new users before each of the tests. So this makes the test more stable for sure. That's what we implemented in our test. Of course, Cypress, I think that it's better a little bit more stabilized than, for example, this Selenium, because Cypress has this auto-wait mechanism, and it handles asynchronous requests better. And the last thing, we were waiting for the quest to be finished, right? which runs the backend. So this was also a thing that stabilized our UI tests.
Okay, maybe 2 more questions. How many teams people were working on changing the testing approach?
Me and 1 colleague. That's why it took 4 months, not 1 month.
That's an easy answer. Okay, was Cypress consistent with producing the different images during visual regression tests? Did it happen that it was not produced for some reason?
We didn't have this kind. We didn't see this kind of issues, to be honest. I think that comparing to Playwright and the visual regression testing, for the Cypress we need to use the external library, which is not good in my opinion, because if the Cypress version changes, and it refers to all the libraries, there are a few libraries that are in the box in the Cypress, right? So for example, the visual regression tool. We use the Cypress image snapshot. After some time, it was deprecated, and we had to use different kind of the forked Cypress image snapshots, right? The library. And for example, in Playwright, with every version, when every new version is introduced for the Playwright, then we are sure that this mechanism for visual regression, which is provided out of the box by the Playwright creators, will work fine with this version, right?
Okay, this was the last question. Thanks a lot. Another round of applause, please, to Tomasz.
Thank you.